Okay, so can you tell me what we are going to be solving for? No, let's read it. What's it say? What does it read?
Real world problems.
Okay, let's start. Class, using linear equations to solve real world problems. Okay, great. So let's come over here to our board and let's look. So today we will, what? Adeline, read it for me. Woo-hoo, we're going to solve equations. Yes? Okay, I know I've gotten it when. Go ahead.
I can write and solve an equation when giving a real world problem.
Okay, so y'all are sitting here trying to figure out when am I ever going to use these equations in real life? Well, here you go. Today is the day that you are going to figure out how you're going to make equations and solve equations when you are faced with a real world problem. So, question, have we finished attendance and fluency? Have we finished launch? We just did. Now we're going to go into lesson 10. Let's go over it. So they want us to consider this price list. So when we're considering something, we're thinking about it, we're looking at it, we're trying to figure out what is happening. So I want you to just kind of look over this price list. Just letting you know, this price list doesn't seem very accurate according to the world standards today. However, we want to check it out and make sure that we have an understanding of what it is saying. So everybody look at the price list for me. Okay, are we looking at the price list? Is the price list helpful to you? $10 for what?
A water bottle.
Oh, that's pretty accurate. Unless you're buying a Stanley and then it's like 40. Okay. So our job right now is to take this information and I want you to determine what this equation represents. So what does this equation represent? So using the price list that you have, what does this equation, or what could this equation represent? Any ideas? What you got, Christopher?
2 water bottles and 10 pounds of this, so equal 25 miles.
Okay, so you're saying that I could possibly get 2 water bottles at $10 and a pack of 10 pencils for $5, and that's going to be my total. That's an option. Anybody else see anything? I'm going to move it up a little bit just so that you can see. Look at your list and see if you can find another one. What you got, Cooper? Okay, 2 drawstring bags and a car magnet. Anybody else? So we're trying to figure out how to make it a real world problem. Any other ideas? Okay, so what I want you to do is I want you to take 2 minutes and I want you to discuss with your group some ideas of, I want you to think of, don't just think of how many things you're buying. I want you to possibly think of how many items you're buying instead. Or try to think of different creative ways that you could solve this problem. Go ahead, 2 minutes, go. Okay, let's discuss. So table 6. What do y'all think the equation 2x plus 5 equals 25 can represent? Okay, but it's asking for 2 times of the same thing. So what would you do instead? Okay, 2 10 packs of erasers. What do you think X represents based on how we interpreted the question? Let's go back to the way Christopher explained it. He said that we would buy 2 water bottles and a pack of erasers, or a pack of pencils, right? So, how could we represent X? What could represent X? It could represent the price of an item, right? So, what's it representing according to what Christopher said? Price of a water bottle. What does 2x represent? We're building on understanding. What does 2 times x equal? Or what does it represent? The price of 2 water bottles, okay? So what does 2x plus 5 represent? Okay, so we have the price of 2 water bottles and a pack of pencils or erasers. It has to be the pencils. Why does it have to be the pencils? Because the pack of erasers is only $1. So it has to be the pencils. Yes? Okay. So what does the 25 represent? The total cost. Okay. What I'm trying to get you to understand is each of the things in the equation represents something that we're going to use. Why is it important to define the variable for the situation? Variable's the what, class? Variable's the what? The letter. Why is it important to figure out what the letter represents? Anybody? Why do you think it's important? And the rule that I'm going to give you is called the read, represent, solve, and summarize rule. Read, represent, solve, and summarize. So at the top of your paper, I want you to write read, represent, solve, and summarize. Read, represent, solve, and summarize. Read, represent, solve, and summarize. Okay, so the goal is to understand that we need to read the problem all the way through and ask yourself, what is this problem asking me to find? So, what are we going to do? We're going to read it all the way through and ask ourselves what? What is this problem asking me to what? Okay. We're going to read the problem all the way through and ask ourselves, what is this problem asking me to find? Then we're going to reread one chunk at a time. And as you read, I want you to ask yourself, what do I know? So where you wrote read, I want you to put, what am I looking for? What am I looking for? And then I want you to write, what do I know? So you're going to have to use your previous understanding of something. So you're writing, what am I looking for? What do I know? Represent. Using a model, a graph, a table, a model, you're going to look at them and see if there's something that you need to figure out how to define your variables. Are they known or unknown? So ask yourself, how is it represented? How is my problem represented? Is it represented with numbers? Is it represented with graphs? Is it represented with tokens? Well, how is it represented? We'll solve the problem. Does my answer make sense? And then we're going to summarize. We always summarize at the end, and the summarization means that summarize your result and be able to justify your reasoning. So we're going to condense our ideas and explain how we know it. So you have 4 things that we are working through to try to solve this problem using all of the words. A lot of people get really, really scared of word problems, but we're not going to get afraid of word problems. We're going to do everything that we need to be able to solve them. So let's look at number 2. It says, a new pizza place is selling discount cards to gain customers. One card offers the cardholder 12 pizzas at a discounted price plus 6 pizzas for $1 each. Another card offers the cardholder 6 visits where they get 3 pizzas per visit, 2 pizzas for a discounted price, and 1 pizza for $1. At what discounted price would the deals on the cards be the same? So we just read the whole thing, right? Now we're going to reread it again, and we're going to break it down so that it makes sense. So, where do y'all think we need to break it apart? What you mean? Okay, so it's telling me that one card offers the cardholder 12 pizzas at a discounted price plus 6 pizzas for $1 each. There's one information. What's my other information? Marley?
The other part is we get 3 pizzas per visit, and then 2 pizzas for just 5 price.
Okay, so what's our goal here? What are we trying to solve for? What are we looking for? Okay, we're trying to figure out what would happen if the cards were the same, right? So what information do we have? What do we know? The what? The amount of deals on each card. Okay, so there's the amount of deals on each card. Anything else that we know? We need to find some way to represent the situation we read about. We can represent it by using a tape diagram, an equation, a graph, a table, or any other way. And representing the situation helps us move from simply reading it to solving it and summarizing our findings. So the question that I want you to do, and the thing that I want you to do right now, is I want you to turn and talk to your table and determine how you can represent the situation by using an equation. So you're going to turn and talk to your table and figure out how to represent the situation by using an equation. Write your equation in your book. I'm going to give you 2 minutes. Go. What are we solving for? What's the whole thing that we're trying to find?
Discount price.
The price of a what? What are we solving for? The pizza, right? The pizza is the goal, yes? So if the pizza is the goal, then we need to represent the pizza with a variable. What variable do you want to represent the pizza with? An X. Okay, so we're representing the pizza with an X. X equals pizza. Y'all okay with that? X equals pizza. Okay? So let's go back to our sentences up here, and they tell us that one card offers the card holder 12 what? Pizzas. Isn't that our keyword? How many pizzas do we have? How many do we have? 12 what? How can we represent 12 pizzas? 12x. Look at that. Okay. So 12 pizzas at a discounted price plus. How do you represent plus? With a plus sign. 6 pizzas for $1 each. So how do you represent that? Why plus 6? Yeah, because the pizzas are how much a piece? $1 each, and you have 6 of them, so how much is the pizza going to cost you? $6, right? So that's for pizza. Haha. Do y'all like how they did that? Pizza pie. Get it? A pizza pie? Never mind. Okay, so that's the pizza pie of this one. Okay, how could we represent this one over here? Let's see what it says. What does it tell us? The card offers the card holder how many visits? Yes, sir. Yeah. Okay, can we get to the equation first and then you can tell me the answer? Oh, you have the equation? Okay, what did you put for the equation? Okay, so, yes, exactly. So, let's look at this. The 6 represents the what in this problem? The visits. And the x equals the what? The x equals the what? The pizzas, right? And they said that you can get 2 of those pizzas, and then it says that you can get another pizza for what? Yes, ma'am. It says you need what? How much is the pizza? $1? Okay, so let's look at trying to solve to figure out when are they going to be the same. Okay, so when something is the same, I want everybody to underline the word same for me. Underline the word same. And when you're underlining the word same, I want you to think about what could same mean. What could same mean? Huh? Equivalent. What does equivalent mean? Equal to each other. So we're trying to figure out when they are equal to each other. So how do we set something up to be equal to each other? What do we do? We could set both equations equal to each other, right? Is that a possibility? Yeah, you're going to set up a linear equation. So let's go ahead and set up a linear equation. Go. Linear equation. Let's go. Set up a linear equation. You can talk to your team about it. Okay, when we're setting up a linear equation, how do we do that? What do we set up? Okay, 12x plus 6 equals 6 times 2x plus 1, right? Now we need to do what to solve? Distribute. What do you notice? Do we need to solve anymore? Let's look for the pattern. What's the pattern? Same variable, same linear term, same constant. So what does that mean? How many solutions is it going to have? Infinite many solutions. And if it has infinite solutions, then what does this mean? It doesn't matter. You're going to get the same discounted price no matter what deal you choose, right? It means that it's going to work the same for both, okay? So what I want you to do is, I want you to look at number 3. I want you to look at number 3. And I want you to work in pairs, and I want you to do the read, represent parts of the RRSS routine. So you're just going to do read and represent. So you and your groups are going to do the RR part. That means that you're going to read it through. You're going to figure out what it is that you need to look at. You're going to ask yourself the questions. What is it asking me to find? And what do I know? And then you're going to represent by how could you define the variables? What are you doing? So I'm going to give you 3 minutes. Go. What did y'all figure out? What's the important information? Okay, in 2020, the city of Franklin's population was about 6,400 people. It's estimated to increase at a constant rate of about 2,000 people each decade. How many years is that? Excuse me. The city of Greenville's population was about 10,000 people. It's estimated to decrease at a constant rate of about 1,200 people each decade. So, in what year will the two cities have approximately the same population? Well, we need to know what information. Franklin's population was what? 6,400, and it increases, that means it's going to go what? Up, at a constant rate of about 2,000 people each decade. Yes? And then the other one says that Greenville's population was about 10,000, and it's going to decrease, which means it's going to go down at a constant rate of about what? 1,200 people per decade. So how could we rewrite this as an equation? What could we do? Yes, sir. Okay, so hold on. 6,400 plus what? 2,000 x, x. Okay, so he's saying we started with 6,400 for Franklin, and then they're growing at 2,000 every decade, right? X is representing our what? Our decade. So X equals our decade. We want to make sure that we define our variable. That way we know what we're solving for. Yes? Any questions on how to do that? We're trying to figure out what we're solving for. So then we have 10,000 is the population of what? Greenville. And then it's going down. It's decreasing by 1,200 per decade. So what is the goal? What are we trying to solve for? Yeah, we're trying to figure out the same population, right? So if we're trying to find out the same, what do? Represent it as a equal sign. Woo-hoo! Look at y'all. Okay, so what we're doing is we're trying to now figure out if we solve this problem, what is our variable going to represent? What's the solution going to be? So what's the first step in solving this problem? What? Combine like terms across the equal sign? What would you like to combine? The x's. Okay, do you want to add 1200x to this side or subtract 2000x? Add. Okay. So we have 6,400 plus, what's 2,000 plus 1,200? 3,200. Now what? Yeah, we're going to subtract the 6,400. 3,200x equals 0 minus 0 is 0. 0 minus 0 is 0. And then 100 minus 64, or we could just do it this way. We borrow, this becomes a 9. This becomes a 10. 10 minus 4 is 6. 9 minus 6 is 3. Is that correct? Did I do math right? Okay, now what do we do? Divide by what? What's really cool is if you want to, get rid of your zeros. It makes life so much easier. So then we have 36 divided by 32. Can we simplify this? Yes. What can we simplify it by? What are they both divisible by? Are they divisible by 4? Are they divisible by 2? Are they divisible by 6? Are they divisible by 8? What are they divisible by? 2? Y'all want to do 2? Everybody want to do 2? 36 divided by 2. 2 into 3 is 1. 1 times 2 is 2. 16. 8. 18. 32 divided by 2. 1. Can we simplify it some more? Huh? We could have done 4, but what are we going to do now? Simplify it by 2 again. And what do you get? Okay, let's go to the next problem. Henry is renting an electric scooter. He's renting an electric scooter. He gets a 24-hour pass, and it costs $10, and then an additional 75 cents for every mile ridden. Then your 72-hour pass costs $18, an additional 25 cents for every mile ridden. How many miles does Henry have to ride the scooter for the total cost to be the same? So, first of all, let's define our variable. What's our variable going to be? Mile. Okay, so X is going to be every mile. That's what we're trying to figure out. So I'm going to give you 2 minutes, 3 minutes, and you're going to work with your partners to figure out if you can write these equations. Ready? Go. What y'all got? How could we set this up as a problem? Go ahead.
The 24 hours has to be an equation by 10 plus 0.75x.
Okay, so I'm going to do 0.75x. I always like my variables first, and the only reason why is because it makes sense to my brain to know that I'm paying 75 cents per mile, but the original pass cost me $10. So I always add that 10 to the end because it's however much you are paying for whatever, and then you add the original, like the starting point. And that's going to equal how much, table 4. How do we set that second part up? What'd you get? Okay, I'm going to do it again like I said, 0.25x plus 18. If you write it the other way around, that's fine. Just make sure that you are paying attention to if they tell you plus or minus, you're going to, if they say a minus something, you're going to have to make sure that you remember to put that subtraction sign. And it's not, remember how we were doing more than and less than? And more than and less than needs to live at the end of the phrase. It's kind of the same situation. So you're going to want to do what's multiplying times your constant first, then we're going to add to the end. It just makes it a lot easier. Okay, now we're going to solve. So what do? We want to what?
Subtract.
Okay, we'll subtract 10 from both sides. 0.75x equals 0.25x plus h. Now what? Divide by 0.5. Okay, this is where we're going to have a lot of people make simple mistakes, and this is why. What is 0.5 written as a fraction? 1/2. Okay, so watch. 1/2 times x equals 8. How do we get this fraction away? We have to do it. Well, we can divide it by the fraction, or we need to multiply by its what? Reciprocal. So if we multiply times its reciprocal, what's 8 times 2? 16. How many of y'all did 4? Okay, so we need to remember that if we're dividing by a decimal, yes ma'am?
I multiplied both sides by 100
Why?
to get rid of the decimal.
I love that idea. Okay, so let's go a little further. I want to explore that idea. Ready? So Marley said that she said, I multiplied everything times 100 to make it so that it got rid of the decimals. Genius idea. You want to know why? Who likes working with decimals? Nobody. Ready? So she said I have 0.75x plus 10 equals 0.25x plus 18. So you multiplied the whole thing by 10 or by 100?
Well, I waited, so,
You went to what part?
I waited to multiply by 100 until I was at 0.50, or 5x.
Down here?
Yeah,
Okay, so you multiplied it times 100 right here?
yeah.
Okay, so she said at this point, she multiplied this times 100. Would we need to multiply it times 100? How many decimal places? 1. So what should we multiply it by? 10. So if we multiply this times 10 and this times 10, we get 5. We move this, right? 5x equals, what's 8 times 10? 80. What's 80 divided by 5? Huh? 16. Same idea. Just pay attention to your place value. Great idea, though. That's a great way to look at it, to get rid of your decimals. You could do the same thing here, though. Since we wanted to get rid of both of those, if you multiplied these times 100, look what would happen. 100 times 0.75x would be 75x plus 100 times 10 is 1,000. Same thing, 25x plus 1,800. You would just have a little bit bigger numbers, but you would end up with x equals 16. So what she did was she made it equivalent on both sides and was able to solve like that. Okay, ready? Let's go to number 5. Are we missing a problem? Oh, I have to play you the lift video. Okay. I'm just very confused.